So let me explain you this trick. This is one of the important trick which you guys should keep in mind whenever you are solving problem related to array or string. So let me explain you the trick over here. So in the two-pointer approach, the technique you need to follow as shown below. The first thing is that use two index location. I and j. Make sense? So you need to use two index location over here. Index location I, j. And since you are using two index location, that means I will be pointing to a specific element and j will be pointing to a specific element. Is this thing clear to each and every one of you? So use two index location over here. Now, the second important point to understand over here is that obviously there needs to be a certain question, right? You need to apply this two-pointer approach in a certain type of question. You cannot blindly apply this question anywhere, this trick anywhere, right? Obviously, it won't work. So if you notice, right, there need to be a certain connection in the input of the question which is provided and the output which is required. For example, in this question, you know that you have an array sorted, correct? And this array sorted makes life easy for you. Why? This is because over there it becomes very easy to apply two-pointer approach. And now you guys will ask me that, okay, how, if an array is sorted, how will you use this trick? So let me explain you via a simple technique. So let's say over here you're having element as 10, 20, 30, 40, 50, 60, correct? This is your array which is given to you as an input. Just try to understand this, correct? And what is your target? Let's say the target which you are trying to look for is, or let's say make it as 29. Okay? So, and let's say the target X which you are trying to look for is 79 over here, correct? So if you know that you need to use two-pointer approach. In two-pointer approach, what happens? I will be pointing to the first index location, I is equals to 0, and j will be pointing over here. Basically, I and j, these are pointing to two different extreme ends of the input, correct? Now, you are interested in finding the pair sum, right? Since you are interested in finding the sum of those two elements, so what you will do? You are going to do ARRI plus ARRJ. Are you guys able to understand why you are doing this ARRI plus ARRJ? You are doing ARRI plus ARRJ because you need to find the pair sum of those two elements, right? Just like in the question it is asked. Find if there exists any pair of elements such that their sum is equals to X. Since you need to check if there exist pair of elements whose sum is equals to X. That is why you are adding these two elements, ARRI plus ARRJ. Is this part clear to each and every one of you? Now, if you will see over here, so what is the value of I? What is the j over here? Can anyone tell me quickly? 0, 1, 2, 3, 4, 5. So the value of j is equal to 5 over here, correct? So what will be ARRI plus ARRJ? Can anyone tell me quickly?
70.
It is 70, correct? So now the thing is that you know that obviously if you are having 70, the sum which you are computing, right? If it is less than 79. So let me give you a very simple example. Let's say you are there in jungle, correct? You are having A for apple, correct? And you are having Z for zebra. And let's say all the fruits as well as animals, they are sorted in alphabetical order. Now let's say if you are interested in searching lion, right? So let's say you are starting in the first end. You see that, okay, this is apple. Now you are in the extreme end, extreme right end. Currently you are at extreme left end and you are at extreme right end. And let's say these two guys are communicating. You are stating, hey, I'm having apple. And zebra will say, hey, I'm having zebra. Now both of them know that, okay, this whatever I'm looking for, it is somewhere in between. Are you guys able to get this thing? So what they will do, the first I pointer, which is over here, right? It will move towards the right and the J pointer will move towards the left. So this is what two pointer approach is. So now what is going to happen is you will see that, oh, I am computing the sum. So what is the sum now? My sum is 70. But since I'm interested in having required sum is my more, right? I need a larger sum. So in that case, what you know that, oh, I am already at 60 and I cannot get more large element. So now you need more larger element, right? So what you are going to do? You are going to move I towards rightward. So what you will do? You will check if ARRI plus ARRJ is less than X. That means the sum which you have computed, which is 70, 70 is less than 79. So what does this imply? This implies that you need more number, right? A larger number so that you could reach closer to this element. How will you get larger number? You are going to leverage the facility that the array is sorted. Now, obviously J is equals to 5. You are already located at largest element. Will you get any more larger element by making any changes to this index location J? Huh, guys? Will you get
No.
any more larger element
No.
by making any changes to this index location J? No, right? So what is the other option which you have? The other option which you have is to make changes in the value of the starting index location. And can anyone tell me how will you get a larger value by making the changes in this index location of I? Any thought process on this?
Move index to the
Array
right
is sorted.
I plus I.
because array is sorted.
Exactly. Exactly. So what you guys are absolutely right. So you will make you will move I towards the right by doing I plus plus. So now the value of I will become 1. Are you guys able to follow this? So the trick is very simple. You will check if ARRI plus ARRJ is less than X. So in that case, you need a larger element. That is why in order to get larger element, you will do I plus plus. Is this thing clear to each and every one of you? This is one of the most important trick related to pointer. If this trick is clear to you guys, then as I stated, right, if that's what my ultimate aim is, I'm going to explain each and every trick in such a thorough way that once you understand it very nicely, right, you guys can extend it for other problems as well via your own thought process. That's why follow this trick very carefully. So is this point clear to each and every one of you why we are doing this I plus plus over here? Because you need larger element and already J is at the largest position, right? You cannot further increment the value of J because otherwise it will be out of this array and you don't have any further elements there, right? That is why the better approach will be to make I plus plus. Now let's say when you have moved I2 over here, correct? Now your I is pointing to I is equals to 1 and J is equals to 5. Now what will happen? Can you guys tell me what will ARRI plus ARRJ give me the value?
It will increase more than the target value.
89.
Exactly. So now basically ARRI plus ARRJ, it is greater than X in this case. Make sense? Why? This is because in this case it is 29 plus 60 is equals to 89. So now you have larger value. So now what you need lesser value, correct? So what in this case you need to do? Can you guys tell me? How do
J
you get a
minus
lesser
J
value?
minus
J minus minus.
You need to do J minus minus. Why J minus minus? Because you know that it is at the largest position. Now you need to decrement J. Are you guys getting my point? Someone could argue that, oh, I can obviously make I minus minus also to get lesser value. No, why? This is because in the previous step, you are moving from I is equal to 0 to I plus plus, right? So you are incrementing I to making I move towards the right and you need to move J towards the left. So this is the technique of two-pointer approach. Are you guys able to follow? That is why you will do J minus minus over here. So now when you do J minus minus over here, what will be the value of J? Can you guys tell me? It will be 4, right? because initially j was 5, now j becomes 4, correct? So now let's say when you're doing ARRI plus ARRJ, ARRI plus ARRJ, so what will be the value? Can you guys tell me?
79.
And what is the target?
79.
So you got the required value, correct? So
Yes,
simply
sir.
check that if ARRI plus ARRJ is equals to x, then simply return whatever the values I and j. You need to check if it is exist or not. Simply return 1. Is the trick clear to each and every one of you? How this is functioning?
Yes, sir.
Yes, sir.
Yes.
Anyone is having any slightest amount of doubt, feel free to ask me. I know. So the thing is that again, I'm going to explain again. This is the basic crux of two-pointer approach. But the thing is that I'm going to explain one more problem via which from the problem itself, you guys can tell that, okay, instantly during the interview that, okay, I'm going to solve this question via two-pointer approach. Are you guys getting my point? So it is very important to understand. So that intuitiveness you need to bring, right? And I'm going to explain you how you need to bring that intuitiveness in the interview itself. So is this thing clear to each and every one of you? Anyone having any doubt or concern? Feel free to ask me. If anyone is having any doubt somewhere, I'll explain once again. But follow this point very carefully, guys. This two-pointer approach is very important. And it is one of the hot topic for the interviewer. Chances are high if you guys go for the interview, you guys can get asked related to the concepts with the two-pointer. The basic tricks remains the same. Start with first pointer. The first pointer will point to the first element. Last pointer is the second pointer will point to the last element. And then do the computation. In this case, we were looking for pair sum value, right? So that is why you are doing the summation of ARRI and ARRJ. And you were checking, as I explained, if the summation of these two numbers is less than x, that means you need number which is greater, right? That is why you are incrementing index I by 1. Now, if you are getting the sum which is greater than x, that means you need number which is lesser than this computed sum. So that's why you're doing j minus minus. And do this until and unless I is less than j. Now, if I and j have already crossed the boundaries, that means you know that you haven't got the pair, simply return 0 in the end because you will not get that pair. Otherwise, if that would have been the case, you would have already computed it beforehand. So is the two-pointer approach clear to each and every one of you that how it works? Anyone having any doubt or concern?
Hi, Ranjan.
Yeah.
Ranjan, I had a doubt like for this kind of questions, do we always have to sort the array?
So in this question, you are already given that it is sorted, right?
Yeah.
So the thing is that you don't have to worry about that. But yes, in case you feel that I need to use two-pointer approach, but there needs to be some correlation, right? Let me answer your question via this example. You asked a good question. Let me explain you. Let's say if your array is, again, you need to find out the pair of some, right? You're having 61, then you're having 5, then you're having 23, then you're having 100, then you're having 60, then you're having 72. Is there any correlation existing over here?
No.
Then now the thing is that let's say you're having 0, 1, 2, 3, 4. Now if you use I over here and you use j over here, so the trick which we applied, right? ARRI plus ARRJ. Then after that we were checking, right? If it is greater than x, then we were making changes in the index location. Are you getting my point? Then why did you do j minus minus? Because you were assured that my moving towards the left will give me a lesser number.
Yeah.
Are you getting my point?
Yeah.
And how did you get that assurity? Because the array was sorted. Can you see the correlation? That is what I stated in second number 2, right? There need to be a certain connection in the input of the question. Are you getting me? Which is provided to you and the output which is required. So what is the connection in the input in this question? That the array is sorted. In this question, you know that you have an array sorted. And what is the output which is required? You need to compute that pair sum. Are you getting my point?
Yeah.
So that's why in this question you need to use, because if there is no connection, right, you cannot use this two-pointer approach because you are not even assured enough that, okay, this trick that you're applying will work or not.
Yeah.
Getting my point, right?
Yeah.
So this is where the two-pointer approach comes into the picture. So is this part clear? I'm going to explain via one more example. It will make things absolutely clear to each and every one of you.
So if the array is even unsorted, first we have to sort and then we have to perform the operations, right?
Yes, you're absolutely correct. Yeah.
Okay.
Otherwise, if the array is not sorted, you won't be assured enough that the next element is greater or smaller, right? Because there is no relation, right? So by sorting, you're getting the guarantee that your input is in that certain format. Getting my point, right?
Yeah.
So that is the beauty of two-pointer approach, right? Otherwise, if the number is random or haphazard, you are not assured enough. So in that case, two-pointer approach won't work. That is why in the trick which I have explained, I have mentioned it specifically. There needs to be a certain connection in the input of the question which is provided and the output which is required. And I'm going to explain this point again by help of one more example. So is this trick clear to each and every one of you, that how you guys can approach any problem related to two-pointer approach? Can you guys see this thing?
Yeah,
So this
Ranjan,
is
I
the
have
curtain.
one doubt.
Yeah,
So
ask
in
me.
an interview, like, do we first explain the brute force approach, or do we know, if we know two pointers directly, talk about this one?
See, I'm going to see, the thing is that you guys can talk about brute force approach, but obviously the interviewer won't ask you to implement it. So if you know the solution, so the thing is, if you want to just do the time pass over here, let's say for 5 minutes, kill the time, you can discuss that. But again, he will ask you any better approach. So my suggestion would be, you guys can kill the time, let's say 3-4 minutes or 5 minutes discussing the brute force approach. But if he's asking you to like think of some better approach, then in that case, try to think in some time, take some time, 1 or 2 minutes, and then suggest in this solution and write the code. Don't waste much time. Otherwise, if you won't be able to complete it, again, he'll reject you directly.
Okay, got it.